Alright, welcome back guys. So this is my version 3 now. I got a 3/8 hole, or pipe with just two holes, and then we got my adjustable wick. So we're going to do a thermal test, and to show you, we get a blue hue right at the tip. It's not hot at the bottom, there is no heat at the bottom. Still no heat, still barely any heat, and just a little bit of heat right there at the tip. So it won't melt the plastic on the piezoelectric or ultrasonic vaporizer. So there's hardly any heat in being brass. It's not the greatest thermal conductor, which is great for this. But anyway, I got a thermometer on my meter here to the end of this copper rod to measure the heat output. So we're gonna just do a standard one, and notice how the bottom has the blue hue. And I know you guys were saying that the blue is where it's most efficiently burned, and it does say that on Google also, but I kind of think the like on a normal torch, when you're close to the torch tip, that's usually like the part where it's not being burned completely. And if you take that into aspect, technically, if I put it all the way down here, that'd be, like the torch tip, and it's not going to be burning as good as it is up here. But they say on Google that the orangish yellow color is from incomplete combustion. So, I mean, Google says that. I mean, it might be right. So, I'm gonna do a test where it's down in the towards the wick where it's blue, and then I'll do a test where it's up in the orange where it's apparently not complete combustion, and then I'll switch over to mine and see what this one's acting like. So first I will do a standard one out here. I'll let it heat up. I kind of did a test before I started this video. I got it to about 230 from doing it this way on the standard alcohol burner. And I'm trying to keep it nice and stable inside that flame. And to be in the same position the whole time. I'm going to lower it down towards the blue part. I'm going to raise it up. Lowering it down. So I'm able to increase the temperature by lowering it down. Raise it up. Might be a long video. Oh, I can't get it any higher than 213. Okay, there we go. So I'm basically almost touching the wick right now. Raise it up. So yeah, it does seem down in this region there is more thermal energy. Well, kind of hard to say now. It's increasing while it's right here. We're at 219. It just has to be in the right position, I think, really. 21. So now I'm raising it. I don't know. Temperature does vary. I have to say around 228 it seems like right here. Well, it's because the flame is moving closer to the rod. That's why it's getting hotter. I don't know if you noticed that. So it's hard to make it exactly the same being done by hand, but we're getting high now. We're pretty far away from that wick. So now if I drop it, now it doesn't seem to be increasing with it down here. Anyway, I'm gonna quit this one, and now I'm gonna jump to mine. So you can see where the temperature is better on my torch here. It's better at the very end of the flame because it gets better burn. Because down in here, that's where the flame isn't burning much, but it's more like on the outer shell. So you can see like right about here is the perfect spot. And also the flame is moving around a lot on me. And get it more stable. So really this one just has to be in that region where it's burning completely. So yes, it does probably need more oxygen, but it's still getting pretty hot. And it's not blue at all in this part. It's just all solid orange. The only blue is actually at the very bottom base here, at the very edge. So if I were to put it here, you can see it's going to go down. So I gotta have it around this region where it's burning totally completely. This is gonna be a long video. And another hard thing to judge is the amount of alcohol consumption between the two. If this flame is consuming less alcohol than the other, so that one would be putting out more thermal energy than this one. There's a lot of variation between the two different burners. So it's hard to see how much consumption between the two. I mean, it's really hard to measure. But we're climbing pretty good now. I just gotta hold it in that perfect region where it's burning hottest. Like right there. So it's climbing pretty good. The difference between the two isn't really substantial, it don't seem like. I don't know, maybe not. It's starting to climb a lot now. They're pretty equal to each other, really. This one might be a little bit hotter. And it's not blue, like you guys are saying, because it's not. I think it is not burning totally efficiently, but it still seems like it is a hotter flame than the standard flame on that burner down there. So we're getting above the standard alcohol burner temperature. If I jump to this one, so it went up when I went in this one slightly. I'm gonna go in the blue part. And I'm gonna go in the orange part. Kind of in the middle. Back in the blue. I don't know what caused that jump in temperature when I went between the two different flames. You think it would have cooled off when I moved it because of the air? But anyway, either way, the two different burners are pretty close to each other in temperature output. Even though this one's not burning completely efficient. I'm gonna probably do what you guys commented. A few of you guys put variable like multiple holes and then put another tube over it to vary the air amount, so I can change the amount of air going in and out, or I should say into the flame. But we're getting pretty close to where it's optimized. I could do a boiling water test too, because things absorb energy differently. But a copper rod is probably like a pretty good example. Anyway, this video is getting pretty long. I'll cut it off here, guys. See you later.